ହେଲା ଆସିଲେ ସେମିତି କରିବୁ।
So today we are going to right. So today we are going to discuss about the photochemistry of carbonyl compounds. Right. So the photochemistry of carbonyl compounds. Generally, the photochemistry of carbonyl compounds. Okay, the carbonyl compounds their SC intersection crossing efficiency is more, isn't it? Because energy of yeah. Right? Okay. So here photo reduction reactions. So compounds depends reduction reactions. So then we know that what is photo reduction? Means the reduction. Reduction means the addition of hydrogen here, right? So in the presence of photolight, H nu light, here where the reduction is takes place, where the proton is abstracted from the donor compound and it will be attached to that particular substrate molecule here, right? So then this kind of reaction is called photoreduction. Yeah. So how reaction compounds acting as a hydrogen donors here, right? So here this is isopropyl alcohol group here and benzophenol, okay, benzahydryl and acetone. These molecules are the compounds are acting as a proton donors here. Okay, they will donate the proton. Right. So you can see the reaction, how this photoreduction is takes place by taking some example here where this particular uh, benzophenone, right? The benzophenone is undergoing the, right? So here the benzophenone, it is carbonyl compound. It is undergoing the photoreduction reaction in the presence of isopropyl alcohol, right? So this is isopropyl alcohol, right? So this is isopropyl alcohol here. So with this isopropyl alcohol, it is donating the proton, right? So this bond undergoes the homolytic cleavage, right? And this carbonyl group also undergoes the homolytic cleavage, right? One of the pi bond in the carbonyl group, it undergoes the homolytic cleavage here. And by combination of this, right, the hydrogen, right, hydrogen radical is there. And here the oxygen radical, right? So the electron on this okay. So this is the benzhydrol due to addition of this hydrogen radical here, right? Hydrogen radical to this right, the radical on this particular isopropyl carbon and this oxygen, right? So here one of the hydrogen combines with this isopropyl carbon here, and one more hydrogen is adding to this particular oxygen carbonyl group here. Then it becomes alcohol, right? And this radical will be neutralized here, right? So that is one kind of mechanism, right? And one of the product here. And one more possibility is this. Okay, so one more possibility is, so after formation of this radical here, right? So that, okay, so this benzene alcohol, and this will be, right, the isopropyl alcohol will be it is obtained as the acetone compound here because, okay, so this it is going to homolytic cleavage and OH bond also undergoing the homolytic cleavage here, right? So then it is converting as a acetone compound here, and this is converting as this particular benzhydrol. Okay, benzhydrol is a major product, and sometimes you can expect this dimer, right, dimerization product also. Okay, so these are the photo reduction product. So you can see the sequence of the mechanism here, that the photoreduction reaction, right? So here first the benzophenone, right, where it is in the ground state level here, right? Ground state singlet, S0, okay, S0, right? The ground state level here, right? So by utilizing the photo energy, right, H nu, by utilizing this photo energy, right? So it is undergoing in the transition, right? So it is undergoing the higher energy level here. Okay, this, right? So this is one, right? Yes, one, right? Yes, not two. So yes, one here. So, okay, yes, not two. Yes, one. Okay, yes, not two. Yes, one here. So this one. Then here further, right? So it undergoes the ISC, right? So ISC means intersystem crossing, because here the benzophenone, right? So here the benzophenone, right? So benzophenone, yes, please keep mute, ma. Somebody disturbing. Okay, right. So here the benzophenone is having the highest ISC value here, right? Because the benzophenone, right? So benzophenone energy gap here, right?
Bro, please mute, bro.
Benzophenone, right? S1 to T1, right? So here the energy gap is 5 here. The difference of energy gap between the S1 to T1 of benzophenone is 5. Okay. So it is having the highest ISC value. Benzophenone is having highest ISC value. So it is more efficient ISC compound here, right? So its ISC efficiency is more. So generally, it easily transfer the triplet energy, right? It easily transfer the triplet energy to this particular compound here. Then it undergoes the ISC here, and where this singlet, right? So it is going to transfer to this particular compound, and it becomes triplet. S1 to here, S0, then S1, then it is going to convert into S3 here, triplet here, right? S3, triplet state. Okay, so triplet state here. Now at this stage, right? In this S3, okay, T3, right? The triplet state, where the abstraction of proton will be takes place from the isopropyl alcohol here. Okay, right? So here you see the proton, abstraction of this proton is takes place, and it is going to combine this particular benzophenone here, right? So here you see. So after abstraction of this one, okay, so this bond also, OH bond also undergoes homolytic cleavage here. And this radical and this radical combine, and it forms this, sorry, not this one, here, so, right? So, okay. So this one, right? So here this bond also undergoes homolytic cleavage, and this radical combine, and it forms the acetone here. Okay, and this particular benzophenone, right? So where this OH bond, right? So one of this particular ketone group is undergoing the homolytic cleavage, and it forms one radical on this isopropyl carbon here, and one radical forms on the oxygen, right? And from this proton, right? So from this isopropyl alcohol here, right? This bond also undergoing the homolytic cleavage here, and it releases a hydrogen radical here. Okay, so this hydrogen radical so combines with, okay, this combines with this isopropyl carbon radical. Simultaneously, another hydrogen radical is combines with this particular, right, oxygen radical here, right? Oxygen radical. Right? It leads to formation of this benzahydrol here. What is the product? Yeah, here. Right? It leads to formation of this this benzyl triad. So radical here, right? After formation of this radical, it may undergo say, okay, so this it may undergo say dimerization, right? Dimerization. It undergoes a dimerization, then you will get this benzophenol. Okay, benzophenol means where the diol compounds here, right? Glycol. So two hydroxy groups. If it is two hydroxy groups, so we call this are the glycols here. So like that, the photoreduction takes place in the carbonyl compounds here. Okay? And here also one more example, you can see the photoreduction example here. So benzophenol, and it is reacting with this toluene, right? This is the toluene here under this photo energy. Okay, so it is going to form the various products here, right? So here the dimeric product, and this is also dimerization product here, and this is the usual product, right? So this is the usual product where this in the toluene, right? So in the toluene, CH2 and hydrogen, right? So CH3. So it is going to break down here, and it is going to form the hydrogen radical and the benzyl radical here, right? Here the benzyl radical. So this benzyl radical is going to combine with this particular, right? So it is going to combine with this particular benzophenone here. Then we are getting this bonding linkage here. And one more hydrogen radical is going to combine with this particular carbonyl group, and it is going to convert this particular hydroxy group, right? So this is the usual product generally, and some unusual product also form. That is your benzphenol, right? Dimeric product here, and this hydrogen donor, right? Hydrogen donor, that is your toluene. This toluene hydrogen donor, this may undergo say dimerization here, and it forms this particular form. Okay, because there is no possibility for abstraction of proton here. That's why it is compulsory. It is undergoing the dimerization only, isn't it? So we are getting this particular what is that? The cyclic. Sorry, we are getting the aliphatic compound here, right? Right. So here also same example where this right in the presence of the amine, right? So amine, it is going to form and not only the protection, all reactions like carbonyl compound, photochemistry of carbonyl compound is very, very important here in the exam point of view and in the what is also CSR also. Okay, so they will in the CSR they will give, and you have to find out the product here, the suitable product like that, right? So here you see this dicarbonate compound. Isopropyl alcohol, right? So this isopropyl alcohol is donating the proton, right? So this is a proton donor here. Okay, isopropyl alcohol is a proton donor, right? It donates a proton here, right? So this bond undergoing the homolytic cleavage, and this is also undergoing the homolytic cleavage here, right? Then you will get the diol compound, or selectively it may, right? The selectively one ketone group undergoing the homolytic cleavage here, right? Means both carbonyl group, both ketones are undergoing the homolytic cleavage, or selectively only one ketone group is undergoing the homolytic cleavage, right? Then you will get these isomeric compounds here, right? So for example, if this, right, this undergoing the homolytic cleavage, right? Then this means this ketone gets reduced here, right? Or another possibility is this may undergoing the homolytic cleavage here. Then this kit these two are the isomers. Okay, these two are the means in borninone. Okay, in the borninone derivative compounds here, and right. So in cyclic compounds. So here where this particular bench pinocol, right? Bench pinocol is acting as a proton donor here. Okay, bench pinocol acting as a proton donor. So on either side of this, right, cyclohexadiene groups are undergoing this particular homolytic cleavage here, right? So this is undergoing homolytic cleavage, this is undergoing homolytic. So the rearrangement of, right, the rearrangement of bonds will be takes place, right? Then here, how do you get this particular here, right? So when this undergoing homolytic cleavage, here one radical here, and oxygen, one radical here, one radical here, right? Here also same thing. Here one radical, here one radical. And this bond also undergoing homolytic cleavage. Then here one radical and here one radical. Now this bond combines with this electron, right? So this electron combines, this means radical combines with this one. This radical combines with this one. Then what you get here? The benzene. Okay, the benzene. And from this benzophenol, right, where this OH bond is undergoing cleavage here, and this release a hydrogen radical. So this hydrogen radical combined with oxygen radical here, and it becomes OH. Here also OH here. Right? So like that, we are getting this. Right? So this dihydroxybenzene and this particular, right? So bench pinocol, right? So bench pinocol is converting into 2 moles of benzophenone here. Right? Here we are getting this bond undergoing homolytic cleavage, and you will get this 2 moles of benzophenone here. Side products. Okay. Now one more example with base. Okay, with amines here. You can see benzophenone here, and where this secondary amine, right? The secondary amine with this alpha hydrogen, here. Okay, so this particular benzophenone is undergoing the reduction with the secondary amine, right? Which is having the alpha hydrogen here. These are the products. Benzophenol is the product here. Mechanism second, right? The properties for this state shape. Okay, because there is no alpha proton here. Here is the alpha proton is there. Okay. So you can see the mechanism how this conversion takes place. Yeah, right. So here the benzophenone, right? So under this particular photolite, right? So it is going to give this product here. And when you see the mechanism, generally here, first it undergoes and it is and after, right? So after that here by ISC, right? So by ISC is sensitization, right? So it is undergoing the triplet sensitization. We call this S12, okay, S12, T3. This is called the triplet sensitization. Right? Triplet sensitization here means the transfer of the energy from singlet to triplet. Right. So it is occupying the triplet state here. Then at this stage, the alpha cleavages, the homolytic cleavages takes place here. Right. So you see this bond, this bond, amine, secondary amine. So one of the CH bond, it is undergoing the homolytic cleavage. Yes, proton transfer, right? The proton transfer will be hydrogen reaction takes place on this. What is it? And it is going to form as a OH, right? And this base, okay, the entire base is going to combine with this. Okay. So all these are reduction reactions. So very important and very easy, I think, because the only thing is you have to abstract the proton, means you select the suitable hydrogen donor, right? So always you can take the benzophenone, right? So any other ketone means carbonyl groups here. You can take benzophenone or the acetone or whatever the compound. These are starting material here, and you take the respective what is that hydrogen donor, right? So it is better to take the isopropyl alcohol. It is a good hydrogen donor here. Okay. Or benzophenol also had benzophenol also one of the good hydrogen donor here. Okay. And exemptions are there here. Here you see some compounds, right? Here the orthoalkyl benzophenones. Okay. So here the benzophenones, right? Here the benzophenone always. Okay. So it unconditionally. Okay, unconditionally it undergoes a photoreduction generally, but the alpha alkyl benzophenone, okay, alpha alkyl benzophenones, they won't undergo a photoreduction reaction, right? The alpha alkyl benzophenones will not undergo a photoreduction reaction here, right? So ortho alkyl benzophenones with alpha gamma hydrogen here, they do not undergo a photoreduction. This is the exemption here, because if the gamma hydrogen is present, so it undergoes a rearrangement reaction. It undergoes a rearrangement reaction, and instead of the photoreduction, it undergoes a rearrangement. Instead of photoreduction, it undergoes a rearrangement reaction, and it forms a photoenol product here. Okay, photoenol product. That's why the condition is right. So if orthoalkyl benzophenones are there, they won't undergo a photoreduction reaction. Instead of photoreduction reaction, they undergo a intramolecular rearrangement reaction here. Okay, intramolecular rearrangement reaction. So you can see the mechanism how this takes place here. Right here, you see this is orthomethyl benzophenone. Right. So here the phenyl group is there. It is phenyl, and at ortho position you can see this methyl group here. Right. At ortho position, the methyl group is there. Okay. So here instead of right here this homolytic cleavage of this bond here, it is undergoing the photoreduction, means rearrangement reaction. Okay, so this bond shifts here, right, and this bond shifts here. Then this will be takes this proton here. So like that, it undergoes a intramolecular reaction, intramolecular rearrangement reaction, and it is going to give the it is going to give your photoenol product here, right? Photoenol product, and this will be right. So this photoenol product formation or the photoenol product right, so mechanism or the pathway, right? So the formation of this one will be confirmed by trapping this compound with okay what is a malic anhydride with the malic anhydride compound here. Means where we are doing the trapping of intermediates. Okay, so when you trap this product with this malic anhydride, where we are getting this derivative, right? We are getting this product. So it confirms that instead of photoreduction, it is undergoing the intramolecular rearrangement reaction here, right? So to check whether it is undergoing the photoreduction or the some other reaction, so we are going to trap with some specific groups here, right? Like this malic anhydride. So then we are getting this product. That means the initial compound is a enol derivative here, right? If enol is there, then obviously we'll get this trapping product. Otherwise, it won't give. If it is photoreduction takes place, right? Photoreduction takes place, we won't get this product here, right? We won't get this product. We'll get the diol here generally, right? We'll get the alcohol here, but we are getting, okay, we are getting this yin means olefin as well as your alcohol. So two functional groups are forming here. So some other reactions takes place here, and that some other reaction, other unusual reactions takes place. Pathway mechanism is established here, and this unusual mechanism establishment is due to presence of this orthomethyl group here. Okay, so this is the exemptional case in the carbonyl compounds for the photoreduction reaction. Okay, right, and for the bulky, right, for the bulkier photoreduction, bulkier carbonyl groups here, bulkier carbonyl compounds, right? The photoreduction is somewhat difficult, right? Somewhat difficult. So because already you see, this is the naphthalene here, right? This is the phenyl group. So you see, there is a bulkier groups are there. If you use the isopropyl alcohol or the benzophenol proton donors here, right? Proton donors. So they won't reduce this compound here because this is the bulkier compound here. That's why in that case, we'll use this tin, right? Tertiary butyl, okay, tin hydrate. So it is low, right? So it is a low, what is that? IP value here, ionization potential here, right? This tertiary butyl tin hydrate, it is low ionization potential value here. Okay, so in that case, when this particular bulkier carbonyl groups are there, in that case, we use this tertiary butyl tin hydrate, right? The tin hydrate reagent as a proton donor here, right? Usually you use the isopropyl alcohol as a proton donor, but here in this case, when this naphthalene derivatives are there, we are using this tin hydrate as a proton donor, right? So here also you see. So here, this is also benzophenone here, right? So benzophenone derivative. This is also benzophenone derivative. Here you can see the, right, the formation of the means it undergoes the photoreduction generally. Okay. So in the previous case, right? In the previous case, so the photoreduction is means ortho substituted, right? Yeah, at ortho position, if methyl group is there, the photoreduction will not take place here. But here, there is no methyl group here. Ortho substitution is there, but it is not methyl group because no proton abstraction takes place here. Okay, so in previous case you see. Okay, so here there is a methyl group here. Okay, at ortho position. Okay, at ortho position the methyl group is there, so it undergoes a rearrangement here. But right, so at ortho position there is no hydrogen here. Instead of hydrogen here the oxygen is there, so no rearrangement takes place here. right? Here the alpha hydrogens are there, but not yet to yet beta position hydrogens are there, but not yet to alpha position here. So no rearrangement is takes place. Only the photo reduction will be takes place here, right? And by photo reduction, you can see here, this bond undergoes the homolytic cleavage, and here this bond undergoes the homolytic cleavage. Okay, and here this radical and this radical combines, and it forms the adjacent cycle 5-membered, okay, pyrrole ring here, 5-membered pyrrole ring here, benzopyron, right? Benzopyron will be forms here, okay, and here the benzopyron saturated, right? Saturated ring is. Then by abstraction of water means removal of water here, right? Upon minus H2O dehydration, we are getting this product, right? Benzopyron derivative here, diphenyl benzopyron derivative. Like that means if at ortho position, right here ortho position, if any hydrogen donors are there, alpha hydrogens, right? Hydrogen donors means the alpha hydrogens are there, then the photo reduction will not take place, right? Here there is no hydrogen here at all ortho position. Okay, it is some other derivative, and here also there pH phenyl group is there, right? It is phenyl group, not the hydrogens here. There is no free hydrogens here at ortho position. So generally it undergoes the photo reduction only, right? And you see this. So this undergoes a homolytic cleavage, this undergoes and they combine and it forms this product here, right? So these are the examples for this photo reduction. And here also same thing with the benzophenone, right? At the para position, some substitutions are there. Okay, and this phenol derivative, right? The phenol derivative, it is acting as a proton donor, and by dimerization, we are getting this product here. Okay, or by abstraction of proton here, we are getting this part. What is that fission derivative? Okay. Right. Next, Patanovich reaction. This Patanovich reaction. So one of the very important reaction for carbonyl compounds. Right, Patanovich reaction, very very important. You can keep 5 or 6 stars for this one. Patanovich reaction. Okay. So here the Patanovich reaction means here it is a addition reaction of the, right? It is a addition reaction, photo addition. Okay, so it is a photo addition in between the olefin and carbonyl compound, right? The photo addition in between the carbonyl compound, okay, carbonyl compound and the olefin here. And the usual products are the cyclobutane derivatives. Okay, oxa cyclobutane derivatives here, or we called it is oxetane. In the heterocyclic nomenclature, we called it is a oxetane here. Okay, like this is oxetane, 4-membered. Okay, oxygen heteroatom containing cycle here. This is oxetane here. Okay, or you say it is oxacyclobutane. Okay, this reaction is known as Patanovich reaction. Very very important here. Okay, right. You see the mechanism or pathway, how it is takes place. Right, fine. Right. So here the benzophenone at ground state here, and by absorbing the energy, photo energy here, H2. So it is going to the excited state here. Okay. So S0 to S1 here, right? S0 to S1. Then here the parallel it is T, right? T0 here, the T1 like that. Right. So here. Okay. So then by ISC here, right? So by ISC, it is the undergoing ISC here, right? ISC, intersystem crossing, right? The energy means it is the transferring the energy to this triplet state here. Okay, so it is becoming, right? So all the reactions in the for the carbonyl compounds, if it is photoreduction or the Pattern-Obuchi addition, right? Pattern-Obuchi reaction and photoadditions here, photoreductions, all three reactions, they will initiate, right? They will proceed in the triplet state only. Okay. And after we'll see the, what is that, alpha cleavages are the Nash type, okay, Nash type 1 reaction, Nash type 1 reaction of the carbonyl compound. So they will take place in the singlet state and triplet state. In both state, it will be takes place, right? So it comes later here, actually, Nash type reactions, it comes later, right? But here, the photoreduction and Pattern-Obuchi cycloaddition reactions, they will, right, takes place in the triplet state only, not in the singlet state. Okay, so after transferring the energy from singlet to triplet, the reaction will be initiated here. Okay, right. So yeah, so upon ISC, okay, so where it acquires the triplet state here, right? Now the olefin are the alkene here, right? So alkene is, it is going to add to this particular, right? Means it is going to approach, right? The olefin is approaching this excited carbonyl, triplet carbonyl state here, right? So both the carbonyl group, means the benzophenone in the triplet state and the olefin, right? So generally, the olefin is not having the ISC value, because for the butadiene or the olefins, right, the ISC is 0, right? ISC is 0 because it is not having any IHC value, because its energy gap for the HOMO and LUMO is a very, means it is high. Okay, so for if you take the butadiene, right? So for the butadiene, how much gap is there? So for singlet to triplet, sorry, triplets, right? How much it is? It is 126, I think, right? It is 60, right? So the difference is how much it is? 66. Sorry, 124 here, this one. So 64. So this much energy gap is there, right? This much energy gap is there. Here 124 kilocalorie, here the 60 kilocalorie. So the difference is 164. But if the energy gap is more, right, then it won't have any ISC, right? For benzophenone, it is very less. It is 5, right? The difference is 5 here. Right? For benzophenone, it is okay, S1 is and T1, right? So here is a how much it is? 74 here, and here is a 69, right? The difference is 5. That's why it is more efficiency, ISC efficiency. Right? So like that, where the olefin is not having ISC here. So this benzophenone is having high ISC efficiency. Okay. So this benzophenone, it transfers the energy, triplet energy to this olefin here. Right? It transfers the triplet energy to this olefin. So it acting as a donor, it acting as a acceptor here. Okay. So after getting this triplet energy, so it is going to the excited here, right? So it undergoes the excited, and you will get here by approaching of this, right, excited benzophenone and this olefin here, right? So it forms a exciplex. Exciplex nothing but excited state here. Xc plus means excited state where the involvement of the both molecules here, benzophenone and olefin, right? So by approaching of these two molecules, it forms some excited state, right? Just kind of transition state. We call it is a transition state in the reaction mechanism, but in the photochemistry, we call it is the exciplex here. Okay, so it forms a excited state here, right? And so the appropriate bond cleavages will be takes place, right? In the exciplex or the excited state, the appropriate bond cleavages are takes place, right? And after bond cleavage, right? After bond cleavage, okay, so the combination of the radical takes place here. Combination of radical, right, in two ways. Here you see, right? Okay, here I will show you. Radical, and here also the olefin also. Okay, here is a methyl. Here is a methyl, and here is a hydrogens. Here is a hydrogen. Here is a radical, and here is a radical, right? Now the combination of these radical is important, right? So generally, okay, so generally here the CO bond formation, okay, the CO bond formation takes place here. Means this oxygen first, okay, the first CO bond formation takes place, okay, first the CO takes place, then CC bond, carbon carbon single bond formation, this first, and this is later here, okay, this is one, it is two, okay, first CO bond formation takes place, later the CC bond formation will be here. And formation of, right, the formation of CO bond from it, which side of the olefin, that is important here. Okay, here you see this side is a what is that, di substitution here. Okay, here two methyl groups are there. Okay, so di substitution here, and this side on left side you see there is no substitution, without substitution, because both are hydrogens here, no substitution. Here is a di substitution, right? So now you can you tell me which okay, so which carbon is more stable here in the olefin after homolytic cleavage? Okay, so here the on right side there is a di substitution radical, on left side there is a no zero substitution radical here. So generally the di substitution radical is more stable. Okay, the di substitution radical is more stable because the methyl groups are plus I groups. Okay, the methyl groups are plus IU groups plus inductive effect groups here. Okay, methyl groups are plus IU groups here. Okay, so after formation of this radical here, right? So after formation of this radical, they gains an electron from the methyl group. Okay, they gains electron from the methyl group, and it becomes stable. It becomes stable because by taking the electron from the methyls, where the electron density is becoming more here, so it gets stabilized by taking the electron from methyl, two methyl groups here. So this radical is stable. Okay, so it won't combine with the oxygen here. Okay, it won't combine with the oxygen. And this side you see in the left side, right? There is no substitution here. So this radical is highly unstable, right? This radical is highly unstable. So it will be combined with oxygen. It will combine with oxygen, and the formation of the bond. Here you see. Radical.
Okay. So if substituted radical, right, then we will get the more stable radical here. If the isopropyl radical, right, will radical, right? So the CO bond formation, right? CO bond formation. So this right, so After which react to milking. Say, two compounds